Hello, in this video I'm going to show you how to graph linear inequalities. Okay, first thing you need to remember about graphing linear inequalities is that it's very similar, almost exactly the same as graphing a linear equation, except there are just a couple of items that you have to consider in addition. However, first and foremost, you need to figure out where the boundary line goes. And so you need to figure out the location and direction of the boundary line. And you do that the same way you would do a regular linear equation. Okay, so for example, we're going to graph y is less than or equal to 3/5 x minus 4. So we want to consider, what does the line y equals 3/5 x minus 4? Okay, that is a 5 here. Let me just kind of fix that so it looks like a 5. So that would be 3/5. There we go. So just like before, you're going to plot your subject, which is the y-intercept, which goes to -4. And then we're going to use our action, or rise over run, to get our next point. So that's a positive slope, so we know it's increasing from left to right. So when we rise up 3, 1, 2, 3, we're going to run to the right, 1, 2, 3, 4, 5. Okay, now we know the location and we know the direction of our boundary. Notice I'm not connecting anything yet, because part 2, we need to consider the type of line that we will use to connect the points. Okay, so we got to figure out the type of line to connect the points. And by that I mean, are we going to use a dotted line or a solid line? Okay, a dotted line means it doesn't include that boundary line itself. However, a solid line does include the points on the boundary line. Okay, and by that I mean the points on the boundary line are going to satisfy this inequality. The points on the dotted line will not satisfy that inequality. Okay, an easy way to tell is, you see how the solid line takes more ink to draw? Well, that matches the symbol that takes more ink to write. And it's kind of like your closed circle when you graph a solution to an equation, linear inequality. Okay, so it's the closed circle. The dotted line, well, that takes less ink. So you're going to use the inequality that takes less ink to draw, or also known as when you use the open circle when you graph the solutions. So when we look at this example here, notice we have a less than or equal to sign, which means it does include that boundary line, which also means, hey, it takes more ink to draw or to write, so we're going to use the line that takes more ink to draw. So this would be a solid line. Now, the third item is shading. See, the big difference between inequalities and equations is, instead of your solution just being on a line, in an inequality you get a whole region. Okay? In fact, you'll notice the graph, because of our line that we drew, is divided into 2 regions. We got a region 1 here and a region 2. 2 sides of the line. Okay? Well, when you have 2 sides of the line competing, only one can be a winner. One's a winner and the other's a loser. Well, to figure out which side's the winner, just pick a point. Pick a coordinate point, plug it into the inequality, and see, and just check to see if it makes a true statement or not. Well, which point do you pick? You can pick any point you want. But between you and me, 0 is the easiest number to multiply and add and subtract, so you may as well just use the point 0, 0 as long as it's not on the line. And you can see 0, 0 is not on the line in this case. So if I test in the equation y less than or equal to 3/5 x minus 4, my pen's not working. Okay, and I want to plug in 0, 0, which means I'm plugging 0 for x and 0 for y, and I'm going to see if I get a true statement. Okay, So notice I get 0 is less than or equal to 3/5 times 0 is 0. 0 minus 4 is negative 4. So here's the big question. Is 0 less than or equal to negative 4? No, it's not. 0 is bigger than any negative number. So 0 is bigger than negative 4. So that makes this 0, 0 gives us a false statement, which means he's a loser. And if this side is the losing side, the winning side must be over here. And since this is the winning side, they win all the shading. So you end up shading the winning side. Let's do another example. Okay, so here we have another example. Y is greater than or equal to negative 1. Well, again, we want to do our boundary line, which means we are going to try and graph the line y equals negative 1, or at least find the location and direction. Well, for y equals negative 1, that just means wherever sorry, I did that in the wrong location. Let's erase that real quick, or let's undo that. Let's try this again. Y equals negative 1 is down here. Okay? Well, it doesn't matter what x value you have, y will be negative 1. So I'm just plotting all these little dots, and you can see the direction. It's the horizontal. Think a slope, dude. It's zero fun. Okay, so it's just a horizontal line. The question is, what type of line? Well, our inequality is a greater than or equal to, so that means it's got to be a solid line, because it's going to include that boundary. Okay, so we're going to have a solid line at y is greater than or equal to negative 1. Now we need to test a point. So now we need to test, I don't know why my stylus isn't working here. Now we need to test the point 0, 0. Well, I only have y values in my equation here. So, oops, sorry about that. I only have y values in my equation, so I'm only going to plug in a 0 for y. So 0 greater than or equal to negative 1. Is that a true statement or a false statement? Well, here's 0, 0. This is true. Okay? So, since that side's true, that makes him a winner. He's giving us a true statement, which means any of these points on this side of the line will give us a true statement. I can plug in the point 0, 4, this right here. If I tested 0, 4, okay, here's my y, is 4 greater than or equal to negative 1? Yep, still true. Watch what happens when I plug in something below the line. Negative 3. So this was true, this was true. If I plug in negative 3, is negative 3 bigger than or equal to negative 1? Nope, sure isn't. It's definitely smaller than negative 1. And notice it's on the side, it's on the losing side. It doesn't have any shading. Okay, so this side was false. Okay, now we have a third example. And I'm actually going to show you this third example two different ways. Okay, one way is to use what's called the intercepts. Let's explain why we would do that. If you'll notice, before, all of our equations had y by itself. It was in slope-intercept form. But this is kind of like those stack 'em and add 'em items. Sorry about that. I don't know what happened to my graph, so we're back again. Okay, so notice that this graph, let's see if I can get that off of there. So notice that our equations, x and y, are on the same side. It's not in slope-intercept form. So when you have it that way, you have two options on how to graph. One, you can make yourself a little t-chart, okay, and this is called graphing the intercepts. And with that, the intercepts means you're going to have one point when x is 0, another point when y is 0. And it's very simple. So for this one, you're just going to let x equal 0. Okay, so we're going to, this is our boundary line, x plus 3y equals negative 12, right? Okay, so I'm going to let x equal 0, 0 plus 3y equals negative 12. Well, that gives me 3y equals negative 12. If I divide both sides by 3, y is equal to negative 4. I'm going to slide this over just a tad. Sorry about that. You'll see why I'm doing that here in a minute. Okay, so we're going to let y equal negative 4. Well, that's one coordinate point, 0, negative 4. But how many points do we need? We need 2. Well, this says we can plug y in for 0 now, or 0 in for y now. So that means I'm going to have x plus 3 times 0 equals negative 12. Okay, well that's 0. So it means I get x equals negative 12. So I'm going to write negative 12 over here for x. So now I have my second coordinate point. Negative 12, 0. Although notice my graph doesn't have that, so I kind of have to create this here. So negative 7, negative 8, negative 9, negative 10, negative 11, negative 12. Pretty close. So we know our point will be about here. We are estimating there. That's kind of a bummer about this type of problem here. If it goes off the grid. Okay. So, but anyway, now we got the location. We know the direction. Remember, step 2 is the type of line. Well, is this going to be dotted or solid? Well, oops, sorry about that. Line, type of line. Let me erase this here. Let me rewrite this. Type of line. Okay, again, is it going to be solid or dotted? Well, we have a less than sign, so that means it's going to take the dotted line. It will not include the boundary line. It's also the line that takes less ink. So we're just going to make a dotted line from one point to another all the way through. Now we got to consider shading. So, I don't know, my pen's not working very well. Okay, so again, we're going to test 0, 0. It's not on the line. 0 plus 3 times 0, is that less than negative 12? Well, 0 plus 3 times 0 is 0. Is 0 less than negative 12? Nope, we already said before, 0 is always bigger than a negative. So this side is false, which makes that side a loser, which means this side has to be true, and it's the winner. Winner, winner, chicken dinner. So we're going to go ahead and shade this side of the graph in. Okay? Now, let's try this again. I mentioned earlier there were 2 ways we could do this problem, and 2 ways we could graph it. So let's try another way. The first way we just did with intercepts. The other way, and we've practiced this before, is to take your equation, okay, oops, sorry. There we go, we're back again. The other way we can do this is to take your boundary line. So in this case we're getting our direction and location, remember. So we're going to consider the boundary line x plus 3y equals negative 12. Okay. Well, there's no reason why we can't solve for y and put this in slope-intercept form. Sometimes that's easier. Okay, so here we box the term we're solving for. Who didn't make it inside the box? A positive x. So it means we got to subtract x. Don't line him up. He's not friends with negative 12. So we get 3y equals, I'm just going to put the negative x in front, minus 12. Now when I divide by 3, divide everything by 3, my 3's cancel. I get y equals, now remember there's a 1 in front of this x, or negative 1, so this is the same thing as negative 1/3 x minus, and then 12 divided by 3 is 4. So now we have our boundary line in slope-intercept form, which means we can plot a negative 4, and we see that the slope is negative, so it's going to decrease like an n. So that means if I go up 1, I have to go to the left 3. So 1, 2, 3. And if I go up 1, I go left 3 more. This way I don't have to create any more points that aren't on the grid. And if I wanted to go down 1, I would go to the right 3. And now, did I need to make all those points? No. I just did that to make myself a little more comfortable with this dotted line, because part 2 is still, we still have the less than, oops, sorry about that. We still have the less than as our inequality, which means it takes less ink to draw. So we're going to use the line that takes less ink to draw, which is going to be a dotted line there. Okay, it also means, probably more importantly, that it doesn't include the points on the line do not make this a true statement. Okay, that's probably the more important point to make there. Now remember 3, option 3 or item 3 is the shading, right? And we always test 0, 0. Well, again, if we go back to the original, we have x plus 3y is less than negative 12. Always go back to the inequality. 0 plus 3 times 0. Is that less than negative 12? Is 0 less than negative 12? Nope, it's still not true. So this side of the equation, or the line, sorry, is still false. So that means the true side is over here, which means this is the side that's going to get shaded, just like before. Okay, I think the important part was seeing the difference on how to graph the line and just kind of remind ourselves that there are 2 ways to approach these equations, or I'm sorry, these inequalities where the x and y are on the same side. I sure hope that helps. Thank you.